right, today we're going to talk about the laws of logs. It's a little bit different than the properties of logs. It's the laws of logs, and it has a lot to do with what exponents do. So the three laws that we're going to talk about today really are based on the laws of exponents. So the first one is called the product rule. And if you remember from exponents, when they have the same base and you're multiplying powers together, you add those exponents. Right, so the exponent of a power is the product is the sum of the exponents of the factors. So 6 plus 2 will give you the 8. Logs are going to be doing exactly the same thing because logs and exponents are actually inverses of each other. So the log of a product is the sum of the logs of the factors. All right, let's look at what this actually looks like. So if I have the log of some number, 12 for instance, that can be broken down into two factors, 6 and 2, you can actually break that up into their two factors. If you're making it bigger, if you're starting with one log and then you're ending up with several logs, we call that expanding. We can also go the other way, however. We can start with an expression that has several logs and then condense it down to something that only has one log. This will help you evaluate some logs. So this is kind of a simple example right now. If I have the log 2 of 8 plus the log 2 of 4, well, I know the log 2 of 8 is 3 and the log 2 of 4 is 2, so I could just say 3 plus 2 is 5 and be done with it. But just to show you that this does actually work, we could actually write this as one log, log 2, and then multiply those two numbers together, call it the log 2 of 32, and you can see this is also evaluates down to 5. Same thing here, right? This here, log 3 of 3 would be 1, log 3 of 27 is 3, so we know this evaluates to 4, but we could also multiply the 3 and the 27 together and get the log 3 of 81, which is also 4. So is this easier? No, absolutely not. If we have something that we can't evaluate on its own, for instance, the log of 40 plus the log of 25. Now remember, if there's no base written, what is the base actually? It's going to be log base 10 because this is called your common log. So I have no idea off the top of my head what the log base 10 of 40 is or what the log base 10 of 25 is. However, if I multiply them together, I know the log base 10 of 1,000 is just 3. So sometimes logs that cannot be evaluated on their own can be evaluated when you multiply them together. Another example, log 6 of 9. I have no idea. 6 raised to what power gives me 9? That's going to be some decimal that I have no idea what it is. But if I change this and condense this log into one log and write it as the log 6 of 36, now I can evaluate that and I know that that's 2. All right, so go ahead and try expanding this log. We will have log 5a. Again, the base here understood is 10. So multiplication is going to turn into addition. So if I'm now expanding this log, I'm going to write the log in front of every single one of these products. So log 5 plus log a. If I have log 6 of b, anytime you have a number that could be broken up into prime numbers, you need to do that. So I could write this as the log of 6 plus the log of b, but then I have to break that log of 6 down into log of 2 plus log of 3 plus log of b. You're going to want to star that in your notes, circle it, highlight it, because this is definitely a spot the kids forget to do. Let's go ahead and expand log 5a squared of b. If you want to stop the video at this point, try it on your own and then continue. That might be a good idea. All right, so I'll have the log 5 plus log a plus log a plus log b. Because I actually have two of these log a's, I'm going to have to write it twice. But these now are like terms, so I can go ahead and combine them and call this log 5 plus 2 log a plus log b. The second law is the quotient rule. Again, it's based on exponents. So if I have x to the 15th divided by x to the 5th, you would subtract these exponents in order to get x to the 10th. The same exact thing is going to happen with logs. So now we're going to actually subtract the logs when we have division. So when we have addition, we're going to multiply, and when we have division, we're going to subtract. So here is your second law of logs. If I have the log with some base and some number divided by another number, I can expand that out by subtracting them. Again, expanding, I would have the log base 5a divided by b. I could simply write that as the log base 5 of a, now minus the log 5 of b. When you have two things in your numerator or your denominator, you're going to want to split the quotient first. So what I mean by that is you want to write this as the log of 3a minus b, and then go ahead and expand this here again as the log 3 plus the log a minus b. You can always check your answer because anything that is positive should end up in your numerator, and anything that is negative should end up in your denominator. So if I have the log of a divided by the log of bc, again I'm going to split my quotient first and call it the log a minus the log of bc. When I expand this, I'm going to have to put it in parentheses because I'm subtracting the whole thing, and then you're going to want to distribute your negative. So don't leave it in your final answer like this. I'd like to see that negative actually distributed. Again, you can check it to make sure. Anything that has a negative sign in front of it would be in your denominator. Anything that's positive should be in the numerator. Here, log 2x divided by 3y. The 2 and the x are in the numerator, so they would be added together. And then the 3 and the y are in the denominator, so those should be subtracted. Go ahead and try this one and see if you can put this one together on your own. All right, so I have to remember that I have to break the 6 into a prime, so it'll be log 2 plus log 3 plus log x plus log y. The 5 and the z squared are in the denominator, so it'll be log 5 minus 2 log z, because I actually have 2 log z's in the denominator. That kind of brings us to the third law, which is the power rule. So you remember when you have an exponent, you have a power raised to a power you're going to multiply. Kind of works in a similar way with logs. Remember, if we have log b of x to the 5th, this is the same thing as saying the log b of x plus 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 the log b of x. I have 5 of them. I can combine my like terms, and this becomes 5 log b of x. So you can see what happens. This exponent really just comes down in front of the log and turns into multiplication. So if I have the log b of x raised to some power n, that n can just come down front and become a multiple. So n times log b of x. If I'm expanding, if I have log the square root of x, well, we can rewrite this as log x to the 1/2. We now know that those are equivalent statements. And I can then take that exponent and bring it out front and call it 1/2 the log of x. Same thing here. I can take this whole thing and raise it to the 1/3 power because the cube root and the 1/3 are the same thing. I can bring this 1/3 out front, and then I can distribute it into each one of these terms. 1/3 log 5 plus 1/3 log of x squared, but this 2 will also come out front, so it becomes 2/3 log x plus 1/3 log y. If I condense them, anything that's subtraction will end up in my denominator, anything that is positive will end up in my numerator, and all these numbers out front where I'm multiplying will go back as exponents. So the first thing I would do is put my exponents up first. So this 3 goes to b cubed, this 2 becomes c squared. And now I can write the word log once. Positive goes in the numerator, and the two negatives will end up in the denominator. All right, you try this and condense this one. Go ahead and pause the video and see how you do. All right, let's take a look. I'm going to put the exponents back first, so this 2 will go back up on the y. Anything negative will be in the denominator, anything positive in the numerator, and I'm going to write log 3 just once. Okay, go ahead and try and condense this one. Again, I'm going to put my exponents back first. I'm going to write the word log once. Anything that's positive will be in the numerator, anything negative will end up in the denominator. It doesn't matter to me whether you choose to write it like this with the square root of a, or if you prefer to write it as a to the 1/2. Go ahead and try this one. Okay, put your exponents up first. Write the word log once. All the positives stay in the numerator, all the negatives stay in the denominator. Expanding works very similarly. I have the log 2 of 4. Now, because this is multiplying, I'm going to add log 2 of x squared plus log 2 of y plus log 2 of the square root of z. I'm going to take my exponents and bring them down. So x squared comes out front. This is really z to the 1/2, so the 1/2 will come out front. But you have to pay attention to what your logs are, because the log 2 of 4 can actually be evaluated. And if your log could be evaluated, then you should simplify it. So this really becomes 2 plus 2 log 2 of x plus log 2 of y plus 1/2 log 2 of z.